Let's take a peek at what we have so far. What we have so far is the following. To differentiate a constant, I simply get 0. Here's my power for differentiation. And the exponential function is the only function that's non-trivial that remains unchanged through the differentiation process. Unfortunately, these are the only types of functions we can differentiate so far. I added to that list some differentiation rules. For example, to differentiate a constant times a function, we simply pull the constant outside the differentiation process. To differentiate the sum or difference of two functions is as easy as coming up with the sum or differences in their individual derivatives, respectively. Now, it'd be nice if the same kind of behavior worked with multiplication and division. But to differentiate the product of two functions, unfortunately, does not give us the product of individual derivatives. So it looks to me like I need to take a break and talk about how you and I are going to differentiate the product of two functions. So let K be the product of two functions. And let's see if you and I can't come up with the derivative for K in terms of f and g. Here's my definition of the derivative function. However, if you're not tired of me saying this, we are going to employ our pre-calculus tools because we're such experts with them. Before I apply those tools, let me just rename K with that. Next, here is where my pre-calculus skill set kicks in. I think this function, which is the product of two functions, evaluated on this input, is going to give me an output, which is the product of the outputs for f and g when the input is x plus h. And something very similar happens over here. And allow me to insert a funky looking form of 0. Anything is a self. I didn't say that very correctly. Sorry. Let me start over again. Anything is a self plus 0. Here's the funky form of 0 I'm going to choose. Oh no, I'm going to run out of room. My goodness. Sorry, that should be over here. Now, what I'm doing is completely legal because I added these two terms in, but they're additive inverses. They cancel each other out by addition. However, something interesting has happened. If I split this one fraction into the sum of two other fractions, I'll get these two terms over h plus these two terms over h. But the limit of the sum is the sum of two limits. So now I got two limits. Next, take a peek at the first one. Notice how in the numerator's position I have a common factor of f of x plus h. Not only can I pull out in front of the fraction, but I can split the limit of the product up to the product of two limits, assuming the individual limits exist. That's going to give me this. Now, with that second limit up here, when I split this up into two fractions, notice how these two terms have a common factor of g of x. I'll pull it out. I now have a limited product. I'll yet again refer to the limit of that product as a product of two limits. So that leaves me with this. Oh, look at that. I barely made it. Now, next on my list. So if you allow h to go to 0, I think this first factor, the first term, just reduces down to an f of x. Notice how if this limit is defined, that represents nothing more than derivative for g. Now, on the other side of this addition operation, I do have two factors with this second term. However, again, assuming this limit exists, that's just a derivative for f. And over here, the limit of anything that has nothing to do with h, as h goes 0, is that thing. That is so significant, I'll give it a name. I refer to this as my product rule for differentiation. And to say it more concisely, to differentiate the product two functions, I get the first times the derivative of the second plus the second times the derivative of the first. Now notice how I have an operation of addition here and an operation of multiplication here as well as here. But those two operations, addition and multiplication, commute. So if you interchange these two factors, or interchange these two factors, or interchange these two terms, it doesn't change anything. I'm not even going to be consistent when I use the product rule of differentiation. It doesn't matter what you do with the order of addition and multiplication, as long as these two factors are associated with one term, these two factors are associated with another term. There's my product rule for differentiation.